Hello everyone, for this video we're going to talk about placing figures in coordinate geometry. Now our learning target for this video, I can identify the coordinates of the vertices of the common figures on the coordinate plane. First, I'd like to share to you the following guide questions that hopefully you can answer after watching the video. Now here, before we start with our activity, let us have our short drill or recall on the properties of these common figures that we are going to place in the Cartesian plane afterwards. So here, name the given quadrilateral based on the stated properties. So first we have, this is a square. Next, according to the property stated, so this refers to rhombus. Next is, for this, opposite sides are congruent, diagonals bisect each other, the diagonals are congruent, this refers to rectangle. And lastly, in general form or in general idea, so what do you call this quadrilateral we're in? Opposite sides are parallel and congruent, opposite angles are congruent, adjacent angles are supplementary. So these are, in general, this is called parallelogram. Okay, so guys, here's the guidelines for placing figures on a coordinate plane. First, use the origin as vertex or center. So later on, you would know or you will realize how important is using the origin as one of the vertices of our given figure, or let's say the center portion of our figure must be the center point or the origin of our Cartesian plane. So what's the importance of that? So later on you would see. Next is keep at least one side of a polygon on an axis. We all know if the given point is on the x-axis or the y-axis itself, then we can say that its coordinate would be 0. So that would be a big help for us to easily identify its coordinates. And next is keep the figure in the first quadrant if possible. We all know the coordinates of our first quadrant in the Cartesian plane are all considered positive, and with that it would be easier for us if we are going to compute for distance, midpoint, and any other processes that we have if we are dealing with positive values. And lastly, use coordinates that will make computation as simple as possible. So yes, so let us look for some ways for us to easily do our task, like identifying the coordinates of the vertices of our figure, or else if we are going to compute for distance and midpoint, then let us make some patterns or formulas for us to easily identify or do the task, like for example in our seat work here. Now let us have our short seat work, and hopefully you can understand all the figures that we are going to explain after this one. So here in our first figure, give the coordinates of point A, B, C, or D without using any new variable. So here we do have our given data already. The coordinates of point C is AB. Now we are supposed to find out the coordinates of points B, A, and D. Now, so before we start with identifying the coordinates, I'm gonna observe first the given figure. If you can see here, it follows the guidelines mentioned a while ago. So the figure is located at the first quadrant. One or two sides of the given figure lie on the x and y axis itself, so that it would be easier for us to identify the vertices afterwards. And with that, let's start. So here, I'm gonna start with point A. Why? It is very simple or easy. As you can see, point A is the location of our origin as well. Therefore, we all know the coordinates of our origin is 0, 0. So we're done. Now, I'm gonna start with point D after our origin. So we have point D. So how are we going to find out the coordinates of point D? So first, you may consider that point D lies on the x-axis. We all know if the point lies on the x-axis, therefore its y-coordinate would be 0. And how about our x-coordinate? If we're going to take a look with our point C and point D, they are collinear vertically. And with that, they do have the same x-coordinate. So, what variable do we use to represent the x-coordinate based on the given data for point C? We do have A here, so therefore, they do have the same x-coordinates, which is A. And we're done. Lastly, for our point B, so you may consider again, since point B lies on the y-axis, therefore its x-coordinate would be 0 this time. And for our y-coordinate, since point B and point C are collinear horizontally, therefore they do have the same y-coordinate. And that would be B. Okay. So therefore, our coordinates for point B is 0, B. And we're done. Next, how about if our square is located at the center of our Cartesian plane, or let's say the center of our figure is the origin itself. So therefore, if that's the case, we can say that the distance of all the midpoints of our segments from the origin would be the same. Okay. Now, so let's take a look with point T. So it's the given coordinates this time. We do have AB again. And now, so I'm gonna start with point C. So as you can see, point D and point C are collinear again, vertically. And with that, we can say that their x-coordinate would be the same, which is A. Okay, so their x-coordinate. So looking at the x-axis, they are collinear, therefore they do have the same x-coordinate. And for our y-coordinate, so of course, from the origin, we can say that the midpoints of side AD and side BC are equidistant. And with that, so whatever the distance of point D and point C with respect to our x-axis, it would be the same. And since the y-coordinate here of point D is B, therefore it should be B as well. But the only difference is, since point C is located at the negative side of our y-axis, therefore it would be negative B. Okay, as easy as that. And next is, moving on to our point B. So same, we're going to use A and B as well. Okay, but the only difference is, take a look with point B, it's in the third quadrant. And looking at the x-axis, it belongs to the negative x-axis and negative y-axis. Therefore, we would have negative A and negative B for the coordinates of point B. And lastly, for point A, so we're going to use A and B same. But as you can see, take a look with our x-axis. Point A belongs to the negative x-axis, so our x-coordinate would be negative. But for our y-coordinate, since point A belongs to the quadrant where the y-coordinate is positive, therefore we would have positive B only. And we're done. Next is, how about if we're going to talk about rhombus? So same, direction, let's find out the coordinates of the remaining points without using any new variable. Now we do have here the clue already, but here in this figure, I'm gonna use the property of rhombus with regards to diagonals. So if we're going to apply the concept on diagonals of rhombus, so we can say that this segment is equal to this segment. So the distance of point B and point T from the origin would be equal or the same. And same manner with point A, it is equidistant with point C from the origin. And with that, we can now start with our coordinates by relating the data to its paired diagonal. So we have for point C, the coordinates, we have k0. And now, let's start with our point A. So since point A lies on the x-axis, therefore its y would be 0. And for our x coordinate, so since point A and point C are equidistant from the origin, therefore they do have the same x coordinates, and that is k units. But since point A is located at the negative x-axis, therefore it should be negative k. And we're done. Okay, how about in our point D? So of course it is paired with point B. And now, so same idea, since point D lies on the y-axis, therefore let's start with the 0x coordinate. And again, so point B and point D are equidistant from the origin, therefore it is h units as well. But then, since point D is located at the negative y-axis, therefore it should be negative h. And we're done. Next, what if the figure or the rhombus is placed this way? So simple. So first is, of course, I'm gonna start with point A, since we all know that point A is also the origin, therefore we can have 0, 0 already as our coordinates. Now, how about point C? So we may start with the idea, since point C is collinear with point B horizontally, therefore they do have the same y coordinate. So y, which is C. So based on our given clue. And how about for our x coordinate? As you can see, we don't have any collinear points vertically to point C. And with that, somehow we need to really analyze the figure. Now here, my clue is, you just simply take a look with how many units does point B with respect to our y-axis. So from here up to here, how many units? So we do have the clue already. It is represented by B units. Okay, so looking at our x coordinates. So that means the distance of point B from the origin, or with respect to our y-axis, I mean, it is represented by B. And now, our problem is, how about the distance of point C from point B? Of course, we are supposed to take a look with our x coordinate, but unfortunately, that is what we're looking for. But of course, we do have the given hints here. Since we're talking about rhombus, all the sides are congruent. Therefore, we can say that side AB is congruent with the DC, and of course, congruent with BC as well, and congruent with AD as well. Now, that means that our target first would be, we should know what is the length of each side of this rhombus. Okay, so here, as you can see, we do have our point A and point D, which we have our coordinate already, and that is A0. And so, as looking at the x coordinate, it is represented by A. Therefore, the distance of point D from point A is A units. And with that, we can say that all the sides of a rhombus, the length is A units as well, right? And now, with this, we can now have our idea. We can have this, combine this length of point B with respect to our y-axis and the length of segment BC. And with that, we can have A plus B for our x coordinates. You may have also B plus A, but it is more proper if we're going to use A plus B. Okay, A plus B for our x coordinate and C for our y coordinate. And we're done. Okay, last. So how about for isosceles trapezoid? So we can apply here the skills that we already discovered or applied in our previous figures, guys. So here, we all know that isosceles trapezoids, we do have one pair of congruent side. So here, this one and this one, they're congruent. And with that, we can say that point C and point D, they are equidistant with respect to our y-axis. Same manner with point A and point B are equidistant from our origin. That means we do have our clue to find the coordinates of point B. So we may start with, since point B lies on the x-axis, therefore the y-coordinate would be 0. Next is, how about the x-coordinate of our point B? So take a look with how did we represent, or what is the given data for the x-coordinate of point A. That means they are equidistant with point B, and that is A. And therefore, we should use A as well here. So here we do have negative A, since point A is located at the negative x-axis, while for point B, it is located at the positive x-axis. Therefore, we would have A0 as our final answer, or so final coordinate. So let me edit this one for a while. So here we do have negative A0. Okay, and lastly, for point D, so of course, so point D is equidistant with point C with respect to our x-axis and y-axis. Therefore, they do have the same coordinates, would be B and C, but the only difference is, since point D is located at the negative x-axis, therefore its x-coordinate should be negative, and therefore we would have negative BC. And we're done. And that's it for this video. Thank you so much for watching. See you on our next video lesson. Bye!